Yes, hello everyone. How are you all? So guys, we are like a couple of days away now from the final NEET exam, which we have been preparing for over the last 2 years. So many of you might have been starting preparation back in grade ninth. Some of us may have started it a little earlier. In fact, grade sixth also some people start preparation in. So whatever time you have spent in your preparation, in 4 days is basically the day when you are finally going to sit in your exam, the NEET exam, and like clear the exam, like probably clear the exam with a very, very good rank, with a dream rank, and then get into our dream colleges and pursue medicine, whichever stream actually you want to get into. So all the very best for that. You guys know that the exam is exactly now on 17th of July, like on this Sunday. And let me give a small recap of the paper pattern, which has been the new paper pattern that we have been following. Like, since last year we started with it. Earlier we know 45 questions were there in physics, 45 chemistry, 19 biology. Even today we have the same. In this year also we have the same pattern, but it's just that there will be more options given this year onwards, guys. You might know about it. Earlier we used to have like directly 45 questions given, but now questions are getting segregated in section A and section B. So in section A in physics, you're going to be asked 35 questions, all the questions MCQ plus 4 minus 1 marking scheme. But in the section B, which will be there in each subject, chemistry, biology also, even in biology, they will be segregated among zoology and botany. So in section B, you are going to be given 15 questions, but out of those 15 questions, you have to attempt just 10. So even today, you have to attempt 35 plus 10, that is 45 questions in physics, 45 in chemistry, and 19 biology. But it's just that you will have options this time in the section B particularly. So 5 questions you're supposed to skip from those questions, and make sure that you are skipping those questions which, like, all, of course you're going to read all the 15 questions in the section B, and accordingly you're going to skip some of them, whichever you feel you are not very much confident about, or maybe the calculation is going to be a bit more. Those questions will skip, rest easy ones we will attempt. But now you might ask, how can we, earlier in 3 hours we were attempting, earlier in 3 hours we were attempting these 180 questions. So how come we can read like 5, 5, 10, and 10 questions here? So total 20 questions extra are there to read at least. We have to attempt 200 only. But since you have to read 200 questions this time, not 180, the time also is a bit more. You guys know about it, that this year onwards, guys, and last year onwards, actually, it's 3 hours and 20 minutes of the exam, contrary to the earlier pattern. So this is earlier, and this is the current pattern. So we have 20 minutes extra to decide among those 50, among those 20 questions, which ones, like among all those questions, which ones are we actually supposed to skip? The 20 questions that we are supposed to skip. So it's very important that we make note of it, that we have to attempt some questions, we have to skip some questions in section B particularly. In section A, there is no choice. So please make sure of it. And on 17th July, 4 days from now, again, I'm saying that same thing again. We have our exam, and whatever we already had a session yesterday. You must have attended the session with Anjali ma'am also, where she had discussed important tips and tricks for biology section. So in this section, guys, today we are going to discuss important tips and tricks, basically question wise, topic wise, what all things are important, what kind of concepts we can focus on in this last minute, in these 4 days, so that we can score maximum in physics. Because this is the feedback that I've had from many of you guys in the past, that physics turns out to be the most difficult one out of all subjects, physics, chemistry, and biology. This is the main pain point that we have in our NEET preparation. Throughout the year we have it, but fine, it's comparatively, definitely it's a little more mathematical, becomes a little more difficult, but it's still crackable. So here today we are going to discuss, if our preparation is to be done in this last 4 days now, what concepts we will focus on, what kind of questions we should practice. So let's start with it. I have collected some of the questions over here. The first question that we're going to discuss, based on the past year papers, is significant digits. Now, the reason I have picked up this concept is because, guys, from this concept, a question was asked in 2020, 2 years back. Last year, a question was not asked directly on the basis of this concept. So according to the general trend, it's most probable to come in this year. Significant digits or approximation, any of these concepts can actually come. So based on this fact, I am going to explain how to deal with questions of significant figures. Now you guys might remember what significant digits basically are. For example, there's a number 1.091300. Can you guys tell how many of the digits are significant? In fact, let me add 10 before this. Now you would notice over here that significant digits go, like there are a couple of rules also that we have learned. You can follow them and you can follow a little bit of logic also. Just see, according to the rule, the zeros which are before the decimal places and before the very first non-zero digit, basically this zero, it's going to be insignificant. Insignificant. But these zeros which are at the end, after the decimal place particularly, all these digits become significant. Why are these digits significant? Because if you put zeros after a decimal place, you are trying to tell that this number is not 1.0913 only. We know, we are sure that these digits are exactly zero. It's not like we have just approximated it and just written 913 only. No, we are very sure that these numbers are zero. It's like that much precise instrument we have. So significant figures actually represent how precise the quantity that we have measured is. That is why it becomes significant. So for example, what is the number of significant digits in this number? So you're going to add, like you're going to count the digits all the way from 1 to the last 0. So 1, 2, 3, 4, 5, 6, 7 significant digits. Okay, this was the basic concept of significant digits. Now let us see this question. Here this question says two numbers are getting subtracted. 0.0099. This number is getting subtracted from 9.99. Take a little while, think what the final answer can be. See, at the first glance, all four might seem correct, right? 9.9, 9.8. If you do the calculation exactly when you subtract them, 9.99 minus 0.0099, it would exactly come out to be 9.9801 meters. Fine. But if we think about it, if you think about rounding it off, then option D will also be correct because it is approximately 9.980. If you approximate it further, it can actually become 9.98 also. And if you approximate it a bit more, then you'll get 9.9 also. So which one of them is actually correct? How do we decide that? So here comes the concept of rounding off or significant figures. Here guys, see, the point is when you're subtracting 9.99, like from 9.99, you're subtracting 0.0099. So what did you assume over here where nothing was written? We assumed zero, right? We assumed that over here, zero must be present. And then we did the calculation and we got 9.9801. But actually, are we very sure that this number was zero? No, since only 9.9 was 99 was written, we're not sure if this number was zero exactly. Maybe rounding off, it was close to this value. So we can never be sure what these digits also are. If we don't know the digits that we are subtracting from, how can we be sure about the answer, the result, that it's 0, 1? We're not sure about it. So here, guys, we are going to, like, this was a rule that in addition and subtraction, you look at the number of decimal places after this. So over here, guys, the least number of decimal places are 2. So you're going to approximate it to 9.98 only. Option C will be the correct answer in this, the option third. Getting this? We cannot determine, we cannot be sure what the digits exactly were, these digits after 9.99. That is why we do not even write them in the final answer. Only digits significant are these first two ones after decimals. So that gives us the option C, 9.98. So that is one question that can come. Let's look at another question, a common question like this. Again, was a question which was asked 2 years back, color coding. Last year it was not asked. So it's highly probable that this question will be asked this year. So guys, in this question, they are saying there's a resistor with color coding yellow, violet, brown, gold. What is the resistance and the tolerance of this resistor? Four options are given. Can you give it a thought? Okay, if you got the answer, you can write it in the live chat also, guys. Yeah, okay. So let's start with it. These are the four colors: yellow, violet, brown, gold. What do these colors actually represent? So let's recall the concept of color coding of resistors. This is how actually the coding is. These four strips and different colored, like there are four strips. Let me number them. Strip A, B, C, or D, or I can call them 1, 2, 3, 4 also. These four strips are there. What do these represent? Actually, the first two represents the digits. Let me write it over here. These first two, this represents digit 1 and this represents digit 2. The third digit represents the multiplier and the fourth one represents the tolerance. I'll help you recall what a little bit this tolerance thing is. Now every color, like there was a trick also, if you might have studied it in among your friends, you must have heard it from your seniors or maybe from someone from the school, maybe your teacher also taught it. There's a shortcut to remember this. B.B. Roy of Great Britain has a very good wife. So this way, actually, with this acronym, you can remember all this order of the colors, and then after that comes gold, silver, and uh, none. Like it's uncolored at all. So what do these colors represent? First of all, black represents 0. So when black is present as a digit, it would represent 0. But if it is present as a multiplier, it will represent 10 to the power 0. Brown represents 1. But if it's present as a multiplier, it will represent 10 to the power 1, and so on. So this table you guys are going to remember. Not very difficult. If you get the pattern, it's very easy to remember this. Now let's see. Here it says that the colors are violet, sorry, first of all, yellow, and then violet, and then brown, and then gold. So what does yellow represent? Yellow represents the digit 4. Violet is the second one. Violet represents 7. The brown, which is the multiplier, represents 10 to the power 1. 10 to the power 1 as a multiplier. And fourth, which is gold, its tolerance is plus minus 5%. So it's simple. We have got it easily. We can say it is 47 into 10 to the power 1. This is the resistance. Plus minus 5% of this. Okay, so that's 470 and tolerance is 5%. This is the answer. But then what's the meaning of this? 470 plus minus 5%. Guys, it basically means that the value of the resistance, we cannot be sure. Like through, it's not a very, because you guys know resistance value actually changes with temperature. So we cannot be sure that at all temperature that's 700, 470. Maybe as the surrounding temperature changes, it can increase a bit or decrease a bit. And maybe when you're using a resistor also, it gets heated up because of its own heat also, its resistance just might increase. So its value is not exactly 470. So they used to say that it can be a little more than this also, and it can be a little less than this also. How much? So let's find out. 5% of 470 ohms, that will come out to be, let's do this, it will be like 753 23.5 ohms. So it's saying that the value that you have of resistance, it could be anything between a range of 470 plus 23.5 and 470 minus 23.5. So between these values, the resistance of it can vary. And that is what was asked in the question. So we have got it. Okay, that is how you can do color coding. As I again repeating, it's a very important concept because it was not asked, the question was not asked from it last year. Very probable that it will be asked this year. So this is one question that you cannot skip. The next question we have over here, the next concept is of photoelectric effect. And many a times we notice a question is always integrated with de Broglie wavelength concept. So let's recall a bit of photoelectric effect concept. Photoelectric effect, if you guys remember, used to say that if there's a sheet and light is falling on it, sorry, why did I draw electron right now? Light is falling on it, basically light in form of photon. That is what we discussed, because photoelectric effect talks about the particle nature of light. So photons of light are falling on it. What's the energy of each photon? Incident photon's energy is h times nu. Now, when it is incident on a metal plate, metal will have a minimum work function, minimum energy that is required to release the electron. So let's call it W naught work function. Some people call it phi naught also. You can see what is given in the question. Now, if the energy with which light is incident, h nu, is greater than the work function W naught, in that case, electron is ejected out. Electron loses the bond and it gets ejected out with some kinetic energy. So kinetic energy you can call half mv square and all. Now here the question is, like here this concept of photoelectric effect is the equation, photoelectric equation as we call it, that the energy that we are giving in E is equal to h nu incident energy goes partially into the work function and partially the rest of it goes into the maximum kinetic energy which is ejected out of it, half mv square. This is called the photoelectric equation. Now on the basis of this question is given. Try it once. I'll give you a minute and then we'll proceed. Now I'm giving you 1 minute because that is the amount of time that you're going to get on an average in a question in NEET exam. So let's try to solve it within 1 minute itself. If you've got the answer, you can let me know in the chat. Okay, let's see guys. Over here in this concept, they are saying, like let's look at the question's solution. That was a concept that we discussed there. Hmm. So here they are saying that electromagnetic wave of some wavelength lambda is incident on this surface, but negligible work function. See, here they are saying this plate, if you imagine, its work function is zero. Like no energy is needed to eject an electron. As soon as you incident photon, electron is ejected at that very instant. So the wavelength of light is given, which is incident. Instead of giving the frequency, they are giving the wavelength. But no worries, we can still solve it. We can say incident energy was h nu, but in this question we are given hc by lambda because lambda is given. Now what is going to be, because if this energy directly goes into ejection of electron, what is going to be the energy with which the electron is ejected, the kinetic energy? Can we say that kinetic energy is going to be directly h nu because work function is zero? So guys, here we can say half mv square is actually equal to, which is the kinetic energy, hc by lambda. That is one equation that we have. We know with what speed electron is getting ejected, right? We can find out the speed from this root 2h c by m lambda. We can find the speed. But this is not what is asked. We have been asked not the speed of this electron, but the de Broglie wavelength of this electron. Now, what was the formula of de Broglie wavelength? De Broglie wavelength basically, guys, is, let me write it, de Broglie wavelength. It says that if you imagine a particle of mass m with moving with speed v in particle form, then in wave form, it can be represented by a wave of wavelength d lambda d, lambda de Broglie wavelength, which is actually h upon mv. This is the concept of de Broglie wavelength. So you can use it over here. You have found out already the speed of it, right? We know the speed of it is, we know that the speed is root 2hc by m lambda. So when we use it over here, we get h upon mass times root of 2hc by m lambda. So when you solve it, you guys are going to get it is equal to root of h lambda divided by 2mhc. So you can square it, bring it on the other side, and then guys, finally we get that lambda is equal to lambda this 2mhc divided by, sorry, I've written h twice over here. This h won't be over here. 2mc divided by h into lambda d, this whole square, well, lambda d into square. So we have got one of the options, which I think is C over here. So C option we have got as the answer. So if it's clear, let me know. If there's any doubt, then also you can let me know. Okay, so now we can move to the next concept, which is photoelectric effect. Sorry, photoelectric current. Because of photoelectric effect only, this photoelectric current can be seen. Again, we are discussing it because last year question was asked. Important concept. Let's see what it says. What is photoelectric current in the first place? First of all, like we know there's a photoelectron which is coming out of a metal plate when light is incident. Photoelectric current, for this concept, there is a whole experimental setup for photoelectric effect, which you might know looks like this. There's the metal plate, and on the other side there's this anode. You connect a battery like this, so you incident light on this like this, and of some energy h nu. There's some work function of the metal plate w naught, and finally electrons are going to get ejected out of it, and they will start moving towards left. These electrons start moving, sorry, not towards left, towards right, towards the positive plate of the battery. Now when they do, they are going to like going from one terminal to the other, and those electrons are going to continue in the closed loop. So that will give some current in this emitter. So that is called photoelectric current, which is this question based on. Now see the question. It's a very interesting question. Light of some frequency 1.5 times the threshold frequency is incident. Like they are saying, if there's a metal plate and the metal plate has a work function, let's say W naught, then the light that we are incidenting is not having a lot of energy. It's having just like frequency is 1.5 times of threshold frequency. Like threshold frequency is what you can say work function is lambda times threshold h times Planck's constant times threshold frequency. So if this is the case, then guys, they are saying that the light which is incident is coming with 1.5 times its frequency is 1.5 times mu naught. Its frequency is this. So what is going to be the incident light's energy? Can we say it's going to be h times this frequency with which it is coming? That is 1.5 times of h nu naught. That is the case. Okay, light with 1.5 times of h nu naught was coming in on a plate with work function h nu naught. So you can imagine some electron will be ejected out. The maximum kinetic energy of the electron will be this minus this 0.5, but that is not the question. The question is, what will happen if the frequency is halved? The incident frequency is halved. Plate is still the same. Its work function is still h nu naught, but the energy of the light, the frequency of the light which is coming, and subsequently its energy, that is halved. It's instead of 1.5, this new incident frequency is just 0.75 h nu naught. What will be the current that will be obtained over here? Just imagine here the incident energy you're claiming is even lesser than the work function. So can we claim no ejection takes place? And if no ejection is taking place, we can say that the current obtained is zero. Like no electron comes out in the first place. How would it even go and reach the plate and current will be observed? There's no electron. Okay, that is another concept which was very important from this year's exams perspective. Now let's move to the next one. Permittivity and dielectric constant. Like it's a simple concept actually. If we just know a couple of formulae, 2-3 formulae, every question that is going to come on this concept we can do. So let's quickly discuss it. Here guys, it says there's a capacitance of a parallel plate capacitor. The capacitance of parallel plate capacitor is 6 microfarad if it is filled with air. Like if we take this capacitor of area A of distance D, then you guys know if it's filled with air, its capacitance is A epsilon naught divided by D. So if we fill this with a dielectric, like this, of dielectric constant, some dielectric constant K, then what is its new capacitance? You guys know its new capacitance comes out to be Ka epsilon naught divided by D. It gets multiplied by K. This is an important formula which we must remember from this exams perspective, NEET exams perspective. Okay, now what is being asked actually? Read the question, try it once, then we'll discuss it. Okay, let's see now. It's given when just air was present, when vacuum or air were present, at that time capacitance was 6 microfarad. So can we say E epsilon naught divided by D? When just vacuum is there, capacitance is 6 microfarad. That is the first thing given. Second thing given is when it is filled with a dielectric, then its capacitance becomes 30 microfarad. Basically, Ka epsilon naught divided by D is 30 microfarad. So from this, what can we conclude? What is the dielectric constant of this material? K is equal to, yeah, we can just divide them. 30 divided by 6 is just 5. So dielectric constant comes out to be 5 in this case. But this is again not asked. The question is, what is the permittivity of the medium? Now, what is the formula for permittivity? What else is given? Actually, permittivity of free space is given. So you guys remember this, that there's a formula for permittivity. It's relative permittivity multiplied by permittivity of free space. That is how permittivity is defined. But do we know that the permittivity of the medium is given as, sorry, a free space is given as 8.85 into 10 to the power minus 12. But do we know the relative permittivity? Yes, actually. Relative permittivity is the same thing as dielectric constant. Relative permittivity and dielectric constant, these are the same things. So all you have to do is multiply this 8.85 with 5 and you get the answer. I think that's the fourth option. That's how we can get it. Okay, I think this is clear to everyone now. So these two formulae are important. This and this. These two things you're going to learn. Then another important concept that we have over here is radioactive decays. This question was already asked last year, but I'll be giving you a brief summary of the different kinds of radioactive decays we have in our syllabus. And we can expect a similar question to be asked, maybe on one of those decays. There are 3 decays that we have in syllabus. One is alpha decay. Second is beta minus decay. And third is beta plus decay. Actually, there's a gamma decay also, but it does not give out any particle as such. It's just energy coming out when nucleus moves from higher excited state to lower excited state. Not very important in this question or as such a very important concept. But these 3 decays are important. So what happens in an alpha decay? So guys, remember alpha decay happens when a heavy nucleus disintegrates because there are too many protons and neutrons. So for example, if there's a element, let's say Z is the mass atomic number and A is the mass number. Then from this, a helium nucleus comes out. Helium nucleus is also called alpha particle. What does 2 and 4 represent over here? Here 2 represents 2 protons and 4 represents 4 nucleons. Nucleons are protons plus neutrons. So this means there are 2 neutrons also. Total there are 4. Okay, so over here, they are saying out of Z number of protons, 2 are gone. So what will be left? 1, like Z minus 2 number of protons, and how many nucleons? Out of A, 4 are gone. So it's going to be A minus 4 nucleons. That is what we'll have. So this is alpha decay. This we should remember. Can you guys tell what's going to be there in beta minus decay? Beta minus. What must be coming out? What comes out in beta minus? What do we mean by beta minus particle? Beta particle minus particle is electron. So guys, electron comes out when a neutron breaks into a proton and electron. Okay, a neutron is breaking into proton and electron. So in general, what will the equation look like? It will look something like this. X, Z, A, just a second. Z number of protons and A number of neutrons plus protons. What happens is in this, one neutron splits into proton and electron. So actually this proton stays inside the nucleus and electron goes out. So one electron will come out altogether, but proton, do you realize, is going to increase because earlier there was no proton, but one not no proton, but one neutron got converted to proton. There'll be one extra proton. So on this Y, they are going to be Z plus one number of protons. One extra proton is there. But what is going to happen to the number of nucleons? Will it increase or decrease, or will it remain the same? A is basically number of nucleons. So that's like the sum of protons and neutrons. If one neutron is decreasing because it got disintegrated, but one proton is getting formed also. So some of them remains the same. So it remains A. And in this process, guys, because neutron is breaking, it's called a particle called anti-neutrino comes out. This is the reaction for beta minus decay. Sorry, beta minus decay. And in the beta plus decay, opposite thing happens. Actually, in beta plus decay, what's beta plus particle? It's a positron. You must have heard of it. Positron. It's like the anti-particle of electron. So in this, what happens is, in general, a proton disintegrates, forms a neutron, and also a positron. This kind of reaction happens. So what will the general reaction of this look like? Here, guys, we are going to claim that if it was XZA, number of protons have reduced because one proton got converted to neutron. So here is going to be Z minus 1. And what about the number of nucleons? A. Total sum is going to remain same. One proton reduced, one neutron increased. So it's going to be A. But a positron comes out, and also a particle called neutrino is going to come out. Neutrino. Okay, so these are the three questions. Now let's look at this question. They are saying three reactions are taking place simultaneously. First is this, second is this, and third is this. They're asking what are the possible decay particles coming out. Just identify them. The first reaction, this one, you can identify it easily. Check it out from here. When number of protons reduced by 1, it's becoming Z minus 1. It should be beta plus decay. So this one is beta plus decay. Second one, number of protons reduced from Z minus 1 to Z minus 3. 2 protons are coming out. In which of these three reactions 2 protons come out? In alpha decay. See, 2 protons came out, it reduced by 2. And the third one, it actually increased. From Z minus 3, it increased by 1 to become Z minus 2. It increases in case of beta minus decay. So it's in the right order, beta plus, then alpha, and then beta minus particle comes out. It's the C option. Okay, that's how we can do this. This you also should remember. Another concept in which question can be asked from nuclear physics is binding energy in the energy formula. Let's see what this actually means. Energy formula, a question has been asked in the past. Energy is equal to mc square. E equals to mc square. Famous Einstein's equation. You guys are going to remember this. In SI units, if I talk about, then what's going to be SI unit of mass? Kgs. Speed of light, 3 into 10 to the power 8 meters per second. Energy in that case will come out in joules. That is one formula. But sometimes, because not, in fact, I should not say sometimes, in nuclear physics particularly, most of the times, it is not expressed in terms of joules. It's represented in electron volts. In fact, mega electron volt. So remember the formula for that also. Energy in mega electron volt is equal to 931 multiplied by, just represent the mass in atomic mass units. If you express mass in atomic mass units, you get the energy by multiplying it with 931, you get the energy in mega electron volt. These two things you should remember. Okay, that was one concept. Another concept that is given on this, on which basically this question is asked, they are saying there's a nucleus with 240 mass number. Basically, it's X 240. It's split into two nuclei, Y 120 and Z 120. Both are equal in mass, identical, right? Both have mass number 120, 120. It's equally divided. But binding energy per nucleon is given. What's binding energy per nucleon? Binding energy per nucleon is as simple as that. Binding energy divided by the number of nucleons, A. So if somebody asks you that binding energy per nucleon of this X is 7.6 mega electron volt, but there are 240 such nucleons present inside it. So guys, what's going to be the binding energy of the X nucleus? Can I say that is going to be 240 multiplied by 7.6 mega electron volt? This is the binding energy. What's binding energy? Binding energy is the amount of energy that was released when this X was created. Right now it is disintegrating. But if all these 240 particles were separate and they came in together to form X, then this much energy was released. Okay, this represents stability and all that stuff. What is going to be the binding energy of Y? Actually, it's going to be equal to binding energy of Z because they are identical. But what's the value of it? It's going to be 120 number of nucleons in them multiplied by binding energy per nucleon, which is 8.5 mega electron volt. So the question is, what is going to be the binding energy of the reaction? So guys, binding energy of reaction is going to be the binding energy of the products. Binding energy of the products minus the binding energy of the reactants. So what is the binding energy of products? 120 multiplied by 8.5. No, actually double of it. 2 times 120 multiplied by 8.5, because there are two such particles, each has this much binding energy, minus 240 into 7.5, 7.6. So this is going to give you the answer 216 mega electron volt. We just need you to subtract them and then we get the answer as option 4. So Himanshu, you're asking which formula, in which formula equals to MC square? What do you mean by that? What's your exact question? So you can ask a question in the chat. By then I'll move to the next concept, which is calorimetry and heat transfer. Guys, calorimetry is basically the concept of like heat given to an object to increase its temperature. That is calorimetry. And similarly, there's a concept of heat transfer also. In calorimetry, guys, we used to say that if there's a body of mass m and its specific heat is S, let me write it, specific heat. Then if we give it some heat, let's say Q amount of heat we are giving to it, from outside we give it. So you can imagine the body is going to get heated up. So if we say that its increase in temperature is delta T, then there's a relation by which we relate them. Q is equal to ms delta T. This formula we are supposed to learn. M is the mass of the object. Q is the heat given. Okay, so over here, what's the question? Let's see. You can read the question once, then we'll solve it. Okay, guys. Now let's start trying this. Here we are saying there are two bodies which are given. One is having radius r1. Another body is having radius 1.5 times of r1. Like it's r2, but it's 1.5 times of it. A little larger body. We are supposed to increase the temperature of both the bodies by same delta T equal to 1 Kelvin. Like for both these bodies, delta T is 1 Kelvin, 1 Kelvin. And specific heat, because they are made of same material, both are solid copper, their specific heat must be same. So they're asking that what amount of heat, what will the ratio of the heat given to them so that they heat up by this temperature? What's the ratio? So the formula we're going to use is mass into specific heat into temperature. But the only thing is, if we do Q2 by Q1 or Q1 by Q2, okay, it's not mentioned. Let's take Q2 by Q1 because in all the four options, numerator is larger. So I am sure that the second body is larger. Its heat should be more. Heat required should be more. So Q2 by Q1 is going to be the second mass into specific heat, which is same, delta T, which is same. First mass into specific heat into delta T. Now see, everything is same except mass. So M2 by M1. So whatever the ratio of the mass is, same is going to be the ratio of the heat required also. What is the mass? We don't know the mass, but we know the volumes. We know the radius. Can we say mass is density times volume, rho times 4 by 3 pi R2 cube, sorry, R2 cube, divided by density of this second mass into its volume, 4 by 3 pi R1 cube. So density cancels density, 4 by 3 pi gets cancelled, becomes R2 cube by R1 cube. The ratio of their radii is cube. So it's going to be 3 by 2 cube. That comes out to be 339, 27 by 8. That is the answer. Option B is correct. Okay, I hope you understood this one. Okay, then let's move to the next one. Variation of acceleration due to gravity, another important concept. So guys, if a question asks, these two formulae are to be used at most probably, that if there's this sphere of radius r, if we are assuming this to be the earth, mass is m, then you know acceleration due to gravity on the surface. On the surface, we know acceleration due to gravity on surface is gm by r square. But if we consider a body at a height small h from the surface, then actually its distance, you can realize it's going to be r plus h from the center. So acceleration due to gravity at height h is going to be gm divided by total distance from the center, r plus h whole square. Sorry, I should write it a little more properly. R plus h whole square. This you are going to remember. And the other formula is acceleration due to gravity at a depth. So for depth, remember this, if there was this earth of radius r, but you try to find out acceleration due to gravity at a depth d from the surface like this point. Then guys, acceleration due to gravity at depth d is the value on the surface into 1 minus d by r. What's the value on the surface? Gm by r square. So Gm by r square into 1 minus d by r, it's going to be the acceleration to gravity at a depth d. So these two formulae we are going to remember. Okay. On the basis of this, you can try this question quickly. They are saying in case A, for this body of radius r, and on the surface, the gravity is on the surface 32. Correct. That's right. That's right. So on the surface, actually this weight on the surface, which is gm by r square, it's given as 72. Okay, but what is being asked? Acceleration due to like the weight of it, it's the gmm by r square. Just a second, guys. Let me write it again. We can say on the surface, first of all, force on the surface is going to be m into g on the surface. That is m into gm by r square. That is gmm by r square, the general formula. This thing is given as 72. That is the first equation. Yeah, correct, astronaut, correct. Now for case B, they are saying that when you take this point at a height r by 2, half the radius of the earth. So what's going to be the total distance if you take r plus h? Then acceleration due to gravity at height h is going to be gm divided by r plus h whole square, r plus r by 2 whole square. If you do the calculation, it comes out to be 4 by 9 of gm by r square. So when we talk about the weight, the force at height h also is going to be, guys, m into gh. That is 4 by 9 times of gm by r square. And gm by r square we know is 72. So it comes out to be 4 by 9 of 72 newtons. That is 32 newtons. That is the answer. Okay, so this variation of g concept is also very clear. If a question comes, we can solve it on the basis of this formula itself. Another common concept that can be used is phase of SHM concept. Let's see very quickly what it is. What is phase? Do you guys know? Astronaut, can you answer, Himanshu? What actually phase of SHM is? What does it mean? Like as you might know, we represent position variation in SHM as x as a function of time is a sine omega t plus phi naught. So in this expression, this thing inside the bracket, this is called phase. The thing which is present inside sine, that is called phase, represented by symbol phi. In phi naught is actually not phase, it's initial phase. It's the value of it at t equal to 0. Phase is the whole thing inside the bracket if you write it in terms of sine only. Okay. Now they're asking what is the phase difference between displacement and acceleration. This is the displacement equation. But how would you write acceleration? By differentiating it twice with respect to time. You guys know that? Acceleration is double differentiation of position with respect to time. If you guys do it, it turns out to be minus omega square a sine omega t plus phi naught. So are they having the same phase? No, actually they are not. There's a negative sign here. You're going to bring that negative sign also inside. Can I say it's going to become omega square a sine omega t plus phi naught plus pi? Do you agree with this? Because there's a rule in trigonometry in math that sine theta plus pi is minus sine theta. That I am using. That magnet, yes, exactly, astronaut. So this minus sign I'm bringing inside by adding a pi over here. So what's the difference in their phase? The phase of the first one is omega t plus phi naught. Second one is omega t plus phi naught plus pi. The difference is pi. In fact, you can say these are out of phase. Okay, so that is the answer for this phase of SHM. This concept you should remember, phase is basically the thing inside the bracket, but only when you write only sign outside, not cos, not minus sign, not anything else. That is first. Okay, one more concept, important concept that we want to discuss is screw gauge. Screw gauge, optical, like these are instruments. There's a vernier caliper also, but it's not a concept that you should cover in the last minute. It's a little lengthy, a little more difficult, but this is easy. If a question comes on it, you can answer this one instantly. Screw gauge has least count 0.01 millimeter. There are 50 divisions. What is the pitch of the screw gauge? Can you guys tell this? Correct, right. See guys, what is the least count of a circular of a screw gauge? Actually, no, in a circular gauge, there first of all, there is a main scale. and then there is this circular scale. Correct. So in the circular scale, it's for example starts from 0. It's going to 1, 2, 3, 4, 5, 6, like this. It's going to go. There will be a certain number of divisions. It's saying in this case there are 50 such divisions. So till 49 it's there 0, 1, 2, 3, 4, and 50th is the 0th one. And it's saying its least count is 0.01. What's least count of a circular scale? Least count is this smallest unit that it actually measures by rotation of 1 unit. Like 1 unit on it measures 0.01 millimeter. So what is going to be the value of pitch? Pitch is what? Pitch is basically the measurement in one circular scale rotation. Like when you rotate it from 0 to 50, how much distance did it cover? So we are saying for every 1 unit, it's covering 0.01, but number of divisions are 50. So it's going to be 0.01 multiplied by 50, that is 0.5 millimeters. That's it. Screw gauge is very simple. If you're not sure about vernier caliper also, screw gauge also, right now you should focus on screw gauge. That was the whole point. Okay, and then last concept, very quickly we can discuss how to find out dimensions of any quantity. Very common question, it is definitely going to be asked. One quantity they will give you from grade 11 syllabus or grade 12 syllabus, you have to find its dimensions. Can you tell quickly which one it is going to be for stress? Option 1, 2, 3, or 4. See, when you're finding dimensions, only one thing you need to know, the formula of that quantity. So for example, stress, what is stress? Force upon area. That is how it was defined. Force per unit area. What is defined as force? Because you want to find dimensions of force. Force is mass into acceleration divided by area. We are supposed to find the dimensions of this. So one by one, you can do that easily. What is going to the dimensions of stress? That is going to be dimensions of mass multiplied by dimensions of acceleration divided by dimensions of area. So dimensions of mass, that's going to be m. Acceleration is distance per unit, like speeds change per unit time. So generally the units are meters per second square. So from that unit also you can guess it's going to be length into t to the power -2, and area is length square. So this comes out to be m. It's L in the numerator, L square in the denominator, L -1 and t -2. So that gives the answer as option 1. So that's it, guys. These are the most important questions according to me for this NEET exam, which is coming up in a few days. These concepts particularly you can focus on. These are like simple questions which you can solve on the basis of understanding from this class also. If you have studied it a little bit by yourself, you must have definitely studied for school exams. It will be sufficient to answer such questions. Okay, so these you can focus on. And like if you are preparing for this NEET coming up on this Sunday, and if you are preparing for NEET, like if you want to prepare for it in future, you are currently in grade 10th, 9th, or any other grade, then you can start your preparation with Ask IITians also. You can find our courses present on our website live over here. Like you can go to the Ask IITians official website, and over here you can find all the new courses over here on the left. You can go to NEET if you want to join our 1-year program or 2-year program or 1-to-1 courses, whatever you want to. You can click on that, find the prices, you can get enrolled in the program. If you want to prepare for other exams like IIT JEE, then also we have programs. If you want to prepare for just school exams all the way from grade 6 to grade 12, you have the possibilities. If you want test series, then also that is there. And if you want some self-study courses, some material by yourself, those resources you can find over here, some past year papers, school exam papers and all. Okay, so all the best for your NEET preparation, and good luck guys. Do well.